Hey, MathCook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathcook.com. Let's MathCook it up. This question says solve the system of equations x squared plus 3y squared equals 11 and 2x squared minus y squared equals 1. So this is a system of nonlinear equations and we are asked to solve. So here are some tips to help us solve. In general, we're going to use substitution or elimination. That's the best method to solve a system of nonlinear equations. Some equations require some preliminary work to put the equation in a form that would be more suitable for applying one of these strategies. Now looking at these ones here, which method would be more suitable to solve? Elimination or substitution? So hopefully you said elimination because notice the x squareds line up, the y squareds, and the constants. So elimination is going to be a great method for this one. The next tip is watch out for extraneous solutions. Sometimes you get these solutions that don't satisfy both equations when solving. And it can be helpful to graph the curves to see how many solution points are possible. And in general, between 1 and 4 solution points are possible, or perhaps no solution at all if the curves do not meet. And lastly, it's always a good idea to plug in your solution points to both equations just to make sure both of them satisfy the equation for the point. All right, so I'm going to go ahead and erase this chart, and let's begin by bringing down our two equations. And again, we're going to do elimination because everything's lined up really nicely. And let's go ahead and cancel out the x's here. So we have a x squared and a 2x squared. So what should I multiply the top equation by to cancel out the 2's? Let's multiply the top equation by negative 2. All right, and then we'll rewrite both equations here. So distributing this negative 2 to both of these here, we will get negative 2x squared. And then negative 2 times 3 is negative 6y squared. And then negative 2 times 11 is negative 22. And then we just bring down the other equation, the 2x squared minus y squared equals 1. All right, so now we're going to combine like terms here. So the x squareds cancel. We add the negative 6y squared minus y squared gives us negative 7y squared. Negative 22 plus 1 is negative 21. Divide by negative 7, we get 3. And then we take the square root of both sides. And then y equals, and we don't want to forget the plus or minus, right? Whenever we take the square root of both sides, we have to put that plus or minus right here. All right, so now we have our y values of the points where these two graphs intersect. So now we need to plug these back into one of the equations to find the x value. So let's go ahead and get that straightened away here. So y equals root 3, and then also y equals negative root 3. So we can plug this into either equation. I'm going to use the top one, just because x squared is by itself here, which is kind of nice, has a coefficient of 1. So we'll bring down our equation there. So I'm going to plug in root 3 for y. I'll plug it in blue. So root 3 squared equals 11. All right, so let's simplify. Root 3 squared is just 3 times 3 is 9. So you have x squared plus 9 equals 11. And then we subtract the 9 over. Go ahead and do that. And then we get x squared equals, so the 9's cancel. X squared equals 2. So then we take the square root of both sides. And remember the plus or minus, so x equals plus or minus root 2. All right. So we're getting a lot of points here. So notice when we plug in the root 3 for y, we get 2 x values. So that tells us that there's going to be 2 points that have a y value of root 3 where these two graphs intersect. So one of the points is going to be root 2 comma root 3. And then the other point is going to be negative root 2 comma root 3. All right, so those are 2 of our points. Now we're going to go on to y equals negative root 3 and plug that in for y right here. So let's go ahead and do that. So x squared plus 3, and I'll plug it in blue. All right, negative root 3 squared is just 3. And so a little trick with that, if you have a radical, and no matter what is underneath the radical, you times it by itself, it's always the number that's underneath the radical. So the radical just kind of vanishes when you square it, basically. Remember, that only works, though, when the number underneath the radical is the same. So root 3 times root 3 is just 3. So we have 3 times 3, which is 9. Subtract the 2 over, subtract the 9 over. Getting a little ahead of myself here. 9's cancel. X squared equals 2. And we're going to take the square root of both sides. So x equals plus or minus root 2. All right. And now we can write our combination of points. So when we plugged in y equals negative root 3, we got two different x values, which means there's 2 points that we get. So the first point is going to be root 2 comma negative root 3. And the second point is going to be negative root 2 comma negative root 3. All right, so those are 2 more points where these two graphs intersect. So for a total of 4 points where these two graphs intersect. Now, the top graph is an ellipse because we both have x squared and y squared, and we have different coefficients, and they're both positive. And the bottom equation is a hyperbola because there's both x and y are squared, but one of them is negative. So these two graphs are going to intersect at these 4 points. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.